Hello everyone, welcome back to my YouTube channel. So, as you can understand from the title, today's video is about machine learning integration into Surface space. So, recently, one of our paper was accepted in Advanced Photonics journal. So, this is a very good journal in the field of photonics. Okay, so I want to explain this paper. So that you can understand what the paper is about and um, how we just integrate machine learning with the PCF-based sensor. Okay, so in this paper, we actually propose a basic model of photonic crystal fiber. So this is the structure of the photonic crystal fiber. Okay, so this is uh, you all, I think you all guys knows about the Photonic Crystal Fiber who are um, not new in my uh, YouTube channel. So if you are new in this actually uh, in the field of Photonic Crystal Fiber, so for you, I can just explain how Photonic Crystal Fiber is this sensor. So you can come from any other sensor field or any other field. You can watch this video actually. Okay. So Photonic Crystal Fiber, this is kind of a schematic view of Photonic Crystal Fiber, 2D schematic view actually. So how Photonic Crystal Fiber works actually. So it's basically a crystal of that actually guide light and um, uh, by creating a difference of refractive index. Okay. So we are actually integrating photonic crystal fiber technology with Surface Plasmon Resonance technology and photonic crystal fiber and this using this two novel physics. Okay. So if you want to know more about photonic crystal fiber, then you can visit our channel. There is lots of explanation about photonic crystal fiber. So for today's video, I don't want to explain more about this. Okay. So this is all about COMSOL results actually. So this model actually shows a very good wavelength sensitivity, 32,000 nanometer per refractive index, and also it has a very good amplitude sensitivity that is um, more than 2,300 per refractive index. Okay, so. And then this is the machine learning part of this model actually. So what we did actually here. So we will get a pseudo of this machine learning model. So you will get understand of what we did actually from this model. Yeah, I will explain you what we did actually in this model. So basically, we create lots of data from our models. So not only from this kind of shape, we try different shape, and we try circular shape or um, circular channel or different. We try lots of different channel, and we calculate all their results. We try different parameters of the model, and then we can collect all the data of okay, the input data are kind of a number of channel or piece, the piece difference between the two ear holes centers and number of ear hole as well as some, okay, so you can get from here. Okay. Uh, so we collect all those data. Okay. Um, and then they were our input data, and then according to those data, we predict the refractive index and their corresponding resonance wavelength. Okay, so this is the refractive index and the corresponding resonance wavelength. So you can see from the results actually. Okay, this is the resonance wavelength with respect to refractive index. Okay, so we predict. So our model actually predict uh, the resonance wavelength with respect to refractive index. Okay, so this is the thing of what is this model actually. So what the advantages of this machine learning model is, you can easily find out the uh, uh, if resonance wavelength of any particular refractive index, so that you can calculate the sensitivity. So if you want low sensitivity or higher sensitivity, you can optimize the parameters like this. Okay, so that's the advantages of this model. And this, okay, so you can see the input data from here. So this the base, this is the thickness of gold, or okay. So to train this model, we actually use gold as the plasmonic material. We didn't try any other plasmonic material. Maybe you can try any other material to train your model. So and then the diameter of central air hole and the number of air holes. So there are the basic input data for this machine learning model, and this was the most dominating parameter, and then thickness of the hole, and then number of air hole, and the more less dominating parameter was the diameter of the central air hole. Okay, so this is actually all about this machine learning model. So if we just talk about the flowchart of this machine learning model, what we did actually, so basically we create a photonic crystal fiber, and then we collect lots of data from the photonic crystal fiber. So the data are piece of the crystal, and then thickness of the gold, and then number of air hole, and the diameter of the center air hole. Okay, so we collect all of this data with respect to results. So the result is refractive index and their corresponding resonance wavelength. Okay, so now we train our model with this those data, and then we test we test the uh, result with some parameters, and um, then we finally optimize our model with respect to then we finally optimize our model using this machine learning model. So so that we get very good results. And then what we did actually, so basically we here we try three different machine learning model: random forest regression, gradient boosting regression, and exit boosting regression. Okay, so we try this three model individually, as well as we combine these three model actually individually. They are not performing very good for higher resonance of sorry, higher reflective index. And if we just combine those three, then they are performing very good. So that's why we actually combine this three machine learning model together, and then we get a very good, good prediction. Okay, so if you just try this machine learning model, you can easily detect any uh, your model's performance, or you can just a few seconds. So you don't need so if you just try to predict results of your model, it will take probably, at least 2 or 3 days. But using this machine learning model, you can predict your data of your model within just a few seconds. So that's the important things of this model. Okay, so I will recommend you read this paper, and you can also try this machine learning model, or you can just improve this machine learning model if you want. So, and I will link this papers DOI in the description box, as well as you can find this paper from our ID. So this is my solar writing. Yeah, we can get this paper from there. Okay, so this is the most recent publication. So you can get that. Okay. Thank you, everyone. Thank you for tuning. If you like this video or if you like our video, you can subscribe, like, or share our videos. So thank you.